looking at section 4, applications and modeling. So we're looking at some real world applications of some of the methods and some of the processes that we've learned so far and how to apply those. One example that we're going to talk about, actually we're going to talk about this a couple times, but is a problem like this, where we've got Cornelius can paint a house in 8 hours, Allison can paint the same house in 4 hours, and we want to know how long would it take them to paint the house together. The natural kind of proportional way we think is to say that it would take them 6 hours to work together, a little bit longer for Allison, a little bit less for Cornelius. But that's really not how it works. Our kind of natural instinct is to find that average, to find the mean, and it doesn't work out to be that way. So I'm going to show you what's going on here, and then we'll do the arithmetic. Okay, so I've got just a note here. Cornelius is 8 hours, Allison's 4 hours. I'm going to draw a picture, bad picture, but a picture of a house. So there we go. It's kind of a ranch-style house. If Cornelius can paint the house in 8 hours, so he can paint the entire house in 8 hours, that means in 1 hour, he should be able to paint 1/8 of the house. 1/8 in 1 hour, 2/8 in 2 hours, 3/8 in 3 hours, half the house in 4 hours, etc. So take him 8 hours to the whole house. That means in 1 hour, he should be able to do 1/8 of the house, or paint 1/8 of the house. Similarly, we have the same house for Allison. In 1 hour, Allison should be able to paint 1/4 of the house, because she can paint the whole house in 4 hours, so 1/4 in 1 hour. Together, Allison can paint 1/4 of the house, and Cornelius can paint 1/8 of the house. So together, after 1 hour, they've painted this much of the house. In a second hour, Cornelius will paint another 1/8 of the house in hour 2, and Allison will paint another 1/4 of the house in hour 2. So really, they're already almost done with the house after 2 hours. In fact, if Allison goes another hour and paints 1/4 of the house, and Cornelius goes another hour and paints 1/8 of the house, they've painted too much. Cornelius doesn't have house to paint at that point. They've gone overboard. So it should take them less than 3 hours. And we can see that by modeling it. They've got 1/4 and 1/8 is 1 hour for both of them together, because they're not painting the same section at the same time. They're painting it together. So the arithmetic, the algebra for that, is when we talk about together, we're usually talking about addition. So we've got Allison and Cornelius together. The sum is going to be, well, let's see, that's 1 hour, 1 out of 4. So 1 out of 4 hours, 1 out of 8 hours. So that's going to be 1 out of X hours. So in 1 hour, we've got 1/4. In 1 hour, we've got 1/8. Together, they're going to paint 1/x of the house. To add with fractions, now we've got the formula set up, which really, that's it. That's how you do it, is you add their 1 hour together, 1/8 of the house, 1/4. How much of the house can they paint in 1 hour? And you add those together, equals 1 over x. To get that, to add those fractions, we need to get common denominators. So I'm going to get 2/8, 1/8. So if I add those, I get 3/8 equals 1 over x. But I have not solved for x yet. I've combined those together. 3/8 equals 1 over x. That means in 1 hour, they can paint 3/8 of the house, which is kind of what we saw here. In 1 hour, they painted 3/8 of the house. So to solve for x, you have really two choices. You could cross multiply and divide. You could do 3 times x is 3x, 8 times 1 is 8, divide by 3 and get the variable by itself. Another way is to simply reciprocate this equation. If you take the reciprocal of both sides of that equation, 3 over 8, if you flip that over, you get 8 over 3. And 1 over x, if you flip that over, we get 1. So x over 1 is x. We've solved it. X equals 8/3. So it'd be 8/3 hours. So x. We don't, and that is correct. We typically don't talk about time in terms of 8/3 hours. We usually talk about it in terms of hours and minutes. So you could simplify or rewrite that, I guess, as 2 2/3 hours. That'd be correct. Or if you really wanted to talk about it in a real world way of speaking, we'd say 2 hours and 40 minutes. All of these are correct. If you answered this problem in any of these three ways, I will accept that as a correct answer. 8/3 hours is correct. 2 2/3 hours is correct. 2 hours and 40 minutes is correct. And any of those are fine. You do, however, need to label. That is important. 8/3 minutes is different than 8/3 hours, is different than 8/3 miles. If you say they painted it in 8/3 miles, that's wrong. So I do need a label on these real world situations. Let's look at another example of the same idea. Water tank. Water tank can be filled by an inlet pipe in 4 hours, and it can be emptied in 6 hours. So they want to know how long will it take them to fill the entire tank if both of those are open. So if you're filling and emptying at the same time, because why not? Why wouldn't you waste water like that? So here we go. Same idea, and I've got a little note. It takes 4 hours to fill, 6 hours to empty. So in this case, we're not combining them together because we don't have two pipes filling. If we had two different pipes that were filling this tank, we would add those together. But in this case, we have a fill of 1/4. So in 1 hour, it can fill a fourth of the tank. 1 hour, a fourth of the tank. And then we're emptying. So we're going to subtract water. And in 1 hour, they can empty 1/6 of the tank. So eventually it will get full because you're adding a fourth of the tank every hour and you're taking out 1/6 of the tank every hour. 4 hours to fill, 6 hours to empty. Again, equals 1/x. We need common denominators. I'm going to choose 12, so I'm going to do times 3. You could have chosen 24 and multiplied them together. That would have worked. So I've got then 3/12 minus 2/12 equals 1/x. 3 minus 2, so we got 1/12 equals 1/x. And just by looking at the fact that this is a proportion, two ratios equal to each other, since 1 equals 1, 12 has to equal x, the answer has to be 12. If I reciprocate both of those fractions or both of those ratios, I get the same thing. You could cross multiply and divide as well, and I should label this. So how long will it take? It'll take 12 hours. It'll take 12 hours to fill the tank if you're emptying it at the same time. I don't know why you would do such a thing, but there you go. All right, so those are those work problems. You're going to see some problems about interest. So a woman has a total of $15,000 to invest. Good for her. And she wants to put it in two different accounts. One that pays 11% and one that pays 12%. We're assuming it's annually. We're assuming it's simple interest, not compound interest. So we're gonna assume some very basic things with this with these problems. So simple interest, annual. These are our percentage rates. We want to find. Okay. So if the interest earned after the first year is $1,690, how much did she invest in each of those accounts? There we go. So again, I've got a couple little notes for myself. $15,000, 11%, 12%, and interest earned was $1,690. We'll talk more about interest in chapter 6, but for now we're gonna leave it as simple interest. Here's the idea. We've got two different accounts. I'm gonna call them X and Y because, why not? I'm gonna say X is 11% and Y pays 12%. So I would get whatever amount that I put in. So X and Y are going to be amounts. They're going to be dollar amounts that I'm putting into these different accounts. So if I put, if I get 11% on whatever dollar amount I put into this account, that'd be 11% X, and I've got 12% of Y dollars. And so I'm going to get a little over 10% of whatever I put in for extra money for interest, a little over 10% for that one. I'm going to add those together and get $1,690. So that's what the question is talking about. It's saying if we get some part of this dollar amount, 11% of this dollar amount, and 12% of this dollar amount together, the interest is $1,690. All right, now let's talk about it in terms of more of an algebra problem so we can solve this. 11%, if we're going to deal with these percentages, we do need to change them to decimals. So 11%, percents are out of 100, so 11% would be 11 hundredths. Of in math typically means times x. 12%, again, out of 100, so 12 hundredths times y equals 1,690. Since I'm using algebra, I'm going to ignore the dollar signs now. I have one equation with two things I don't know. I can't really solve that. It's not possible to solve for x and y at the same time with only one equation. We're not going to learn about different ways to solve multiple equations right now. I'm just going to give you an idea of what we're doing. So pretend this is a barrel of money. That's fun, right? A barrel of money. In that barrel, there's $15,000 total. $15,000 total. I'm going to take some amount. So that's not halfway, it's not three, it's just some amount of that money. And I'm going to put it in this first account here, 11%. So this is my X. The rest of it then is going in the other amount, in the other bank, that'd be Y. But when we talk about how much is left, so I put this much in this account here. The remainder, whatever is left, is going in the other account. So when we talk about what's left, what we're really saying is 15,000 minus X. We're taking that $15,000 and we're taking out some amount. And then whatever's left is 15,000 minus X. So this equation really could be written this way. Instead of Y, I'm going to put the remainder, 15,000 minus X. All right, now I have one equation with one unknown, one thing I don't know, one variable. So I'm going to simplify the problem. I'm going to distribute through the parentheses. 0.11 or 12 times 15,000 is going to give me 1,800 minus 0.12x. There we go. I can combine my like terms here. 11 hundredths minus 12 hundredths is going to be negative 1/100th, which alarms me a little bit because I've got a negative dollar amount here. However, I think it'll work out because if I subtract 1,800 from both sides of that equal sign to solve, to isolate that variable, I'm going to get negative 110. There we go. And I'm almost done. I'm going to divide both sides by negative 1/100th. I think I have just enough room here for my answer. She put $11,000 into that first account. Now, if she put $11,000 into the first account, whatever's left went into the first or the second account. So 15,000 minus 11,000 should be then 4,000 for the other account. Now, the one that was X, the one that was Y, the first account versus the second account doesn't really matter because well, I guess I should say that differently. The 11% is going to be the same amount either way. What variable you use doesn't matter. So if you assigned this one to be X and this one to be Y, that doesn't matter. As long as you are using this method of taking the difference and remembering which variable went with which account, you should be good. And so when you're setting this up, this is where showing the work comes in. If you have X is 11,000, Y is 4,000, and I can see in your equation that 11% is your X and Y is your 12%, then I should be able to see that. And that should be clear. And again, label. Okay, now we are getting to the most difficult questions. We got 2 questions left. We have a tour bus. Normally leaves for its destination at 5 o'clock, and it goes 378 miles. However, today the bus driver is running a little bit late, and leaves at 6 o'clock. So it needs to get there at the same time, though. So the driver drives 9 miles per hour faster than the normal speed and got there. We're assuming that he got there on time. So we want to know what's the normal speed of the bus. This is where we're going to use what's called the DIRT formula. Distance equals rate times time. And I've got this table here, and I'm gonna come back to this. But distance equals rate times time is the DIRT formula, and we're going to use that to help us quite a bit. So I've got this table. I'm going to copy that table onto my sheet here. So I've got. I'm just going to use D, R, and T. So distance equals rate times time. I'm going to make a little table. These tables are very helpful in terms of organizing what's going on. Okay, so in a normal week, so I'm going to go with normal. In a normal week, the distance is 378 miles. The rate, we don't know the rate. I'm just going to put R. And the time, we don't really know the time. We don't know how long it takes him to get there. We just know that this week it took him a little bit longer. Or excuse me, it took him less time because he left later. So this week, I'm going to say this week. Doesn't really matter what you label these as long as you remember which is which. This week, he still goes the same distance. I'm assuming the bus driver is a he. I don't know if it said so or not, so I apologize if it's not a he. 378 miles. The rate. Now this time the rate is different. The rate is faster. So this week he is going 9 miles per hour faster. So it's the rate plus 9. The time is a little bit shorter actually. It usually leaves at 5 o'clock. So we left at 6. So it was 1 hour less time to get there. You got there faster. Time minus 1. That is by far one of the most difficult parts, is writing this table. The distance, the rate, and the time may or may not be the same depending on what's going on in the situation. All the problems are slightly different, and that is an issue. So we've got the distance was the same. The rate we don't know, the time we don't know. But we know that this week it's the rate plus 9 miles an hour and the time 1 hour shorter. Here's the trick. I'm going to solve this equation for time. So I'm going to divide by the rate. I'm going to get that distance divided by rate equals time. And this is an important trick for solving these. So if I do that with both of these two equations here, I get 378 divided by rate equals time for this one. For the second one, I get 378 divided by rate plus 9 is time minus 1. I'm going to add 1 to both sides here, 378. And this is where all the problems are going to be slightly different, is what do you do with those two ratios? Sometimes you combine them, sometimes you don't, and you'll see that as you go. Now that they are both equal, sorry, and I didn't write the minus 1, I'm sorry. I got distracted by myself. 378 over rate plus 9 minus 1 plus 1 equals time. There we go. Okay. So now they're both equal to t. I'm going to set them equal to each other. I'm actually going to grab a different piece of paper for this because I think I'm going to run out of room. But what I'm doing is I'm taking this equation equals t. I'm saying since this equation also equals t, I'm going to set them equal to each other. I'm going to take that and move over to a different piece of paper here. So again, I'm taking that same equation. I'm going to write it right up here. There we go. Okay. I need to get a common denominator. We've done this before in the last lesson. So I'm going to multiply this one by r plus 9. I'm going to multiply this one times r. And 1, I'm just going to make 1 into, so 378 times r plus 9 we got r plus 9 times r there, equals 378 times r over r plus 9 times r. So now they have that common denominator. I'm just going to make this r plus 9 times r plus 9 times r. So that's 1. Anything divided by itself is just 1. All right, all common denominators, so I can ignore the denominators, or effectively ignore the denominators. I'm going to distribute through 78r plus 378 times 9. I get 3402. 378r plus, I'm going to distribute through r squared plus 9. So again, all the denominators were the same, so I effectively ignored them, and I'm just worried about the numerators. The 378r's, if you subtract, you'll cancel those out. And if I subtract 3,402 from both sides, I've got a quadratic that I can solve because it equals 0. I'm not going to try and factor this because I can't think of two numbers that multiply to negative 3,402 that also add to 9. So I'm going to use the quadratic equation. Opposite of b plus or minus the square root of b squared. I could have used completed the square, but I'm not going to. Minus 4 times a times c all over 2a. And if I do that, I'm going to end up with 54, or let's see what the other one's going to be, negative 63. And since I know I can't go negative 63 miles per hour, I'm going to say that the answer is 54 miles per hour. And that is one important piece of that quadratic equation. It is going to give you two different results. Some of them don't make sense when you talk about a real-world situation. In this case, negative 63 miles per hour does not work. So the solution is he was going 54 miles per hour on a normal day. That was the normal rate. Those take a fair amount of practice. And so I'm going to leave those to you to practice. Please email me if you have questions about them, if you're not sure if you're doing it correctly, if you are stuck, let me know, and I can try and show you some pictures and walk you through those. Last one, I think this is getting to be a long video, but this is it. The length of a rectangle is 3 inches less than twice the width. We're going to find, and we know the perimeter. We're going to find the length and the width. Okay, so I'm going to draw a picture, and I'm going to move over to my document camera. Okay, so it said that the length of the rectangle, I've assigned this to be the length, is 3 less, minus 3 less than twice the width, 2 times the width. The perimeter is 48. To find the perimeter of a rectangle or triangle or any shape, you add up all the sides. This side is also going to be W, because on a rectangle, opposite sides are equal in length. If I add those together, I get 2, 4, 5, 6 W's minus 6 equals 48. I can then solve for W, get 54. W is going to equal 9, I believe. And so that is, 9 inches. Does it say? I missed it. Inches, yes. So the width is going to be 9 inches, which means the length is 3 less than twice the width. So twice the width should be 18. 18 minus 3 is going to give me a length of 15 inches. And that's how we can use that geometry to solve.